Hi learners! In today's video, you will learn how to partition a directed line segment on the coordinate plane without using a formula. More specifically, you will learn a quick way of locating the point that will divide a directed line segment into two parts with a given ratio without, as I said, memorizing any formula. Strategies in analyzing and solving problems related to the topic are showcased to let you gain an understanding on how these are done so that you'll be able to successfully answer geometry problems similar to these in the future. If your lesson is on partitioning a directed line segment on the coordinate plane, or if you have an assignment on this topic, or if you're preparing for a test in math or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Let's go and start the ball rolling by first recalling what a segment is. On the previous video entitled Introduction to Geometry, Understanding Geometric Terms Part 1, we described a line segment as a part of a line bounded by two endpoints and contains every point on the line that is between its endpoints. On the diagram is line segment AH. This can also be named as line segment HA. Did you wonder why the name can start with A or H? It is because a line segment just describes a length. If the length is 3 units, you can start measuring from A or H. You will get the same thing. On the other hand, a directed line segment AH has length and direction. Because it has direction, it has a starting point, the initial point, and a terminal point. The convention is that the first letter of the segment's name represents as the initial point. For the directed line segment AH shown on the diagram, point A is the initial point, and point H is the terminal point. Because line segment AH has direction, it is different from directed line segment HA, for the latter has H as its initial point and A as its terminal point. Now that we know what a directed line segment is, let us go into partitioning a line segment. The word partition means divide into a certain ratio. To do this, we have to look for a partition point that will exactly divide the directed line segment with a given ratio on the coordinate plane. Let us look at this diagram. Here, point H partitions the directed line segment MN in a ratio 2:1. What does the ratio 2:1 exactly mean, learners? It means that segment MN will be partitioned into 2 with H as the partition point. Furthermore, it means that segment MN is divided into 3 equal parts, with segment MH taking 2 parts of the 3 parts, and segment HN taking 1 part of the 3 parts. The ratio comparing MH to HN, which is 2:1, is a partition ratio. This is also referred to as part-to-part ratio, hence adding the 2 parts will give us the whole length of segment MN, which is 3 parts in this case. On the same diagram, we can also compare part of the segment MH to the whole segment MN, or vice versa. MH is 2 parts of the whole MN, which is 3 parts. Comparing MH to the whole MN gives us this ratio 2:3. This is a part-to-whole ratio. Understanding these ratios is important, for this will be our guide in locating the partition point of directed line segments. Okay, we will work on this sample problem so you will know how this is done. Here's the problem. On a coordinate plane, the endpoints of directed line segment MN are M, -5, -3, and N 4, 9 as shown on the figure. Point H lies on line segment MN and divides it into 2 such that the ratio of MN to HN is 2:1. What is the coordinate of point H? Option A, -2, 1. Option B, 1, -2. Option C, 5, 1. Option D, 1, 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? We are asked to find the coordinates of point H that would divide MN into 2 segments such that the ratio of MH to HN is 2:1. What are given? We're given the endpoints of the directed line segment MN, which are M, -5, -3, and N, 4, 9. We are also given that point H lies on segment MN and is dividing the segment into 2 such that the ratio of MH to HN is 2:1. A figure is given. Okay, so the problem gives us a ratio of MH to HN, which is 2:1. First of all, what type of ratio is this? Take note that point H lies on segment MN. You are right, this is a part-to-part ratio or partition ratio. This ratio is telling us that segment MN, the whole segment, is divided into 3 equal parts. That is, 2 parts plus 1 part equals 3. Let us examine the figure if we can see these 3 equal parts on the diagram. Look at these, learners. Do you see this? Here's another one. And another one. Now, how do we know that these are the 3 parts? We have to find out if they're equal in length. If they are all equal in length, then these are the 3 equal parts dividing the whole segment MN. To check if they are of equal length, we have to count the run and the rise of each segment. Let's go. On the run of the first part, we have 1, 2, and 3. Counting on the rise, we have 1, 2, 3, 4. On the run of the second part, we have 1, 2, and 3. Counting on the rise, we have 1, 2, 3, 4. And on the run of the third part, we also have 1, 2, and 3. Then on the rise, we have 1, 2, 3, 4. These are indeed the 3 parts that divide the whole segment MN. Now, we will locate H by referring to the given partition ratio MH to HN, which is 2:1. Let us look at our diagram and count 2 parts from point M moving towards N. So we count 1, 2. We got it. This is where partition point H is located. And its coordinates are 1, 5. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so it is option D. Now, I hope you were able to follow, learners. Okay, let us look at the next problem. Here's the problem. On a coordinate plane, the endpoints of line segment OP are O, -5, 2, and P, 7, 6 as shown. Point R lies on line segment OP and divides it into 2 line segments such that the ratio of OP to RP is 4:1. What are the coordinates of point R? Option A, -5, 4. Option B, -2, 3. Option C, 1, 4. Option D, 4, 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? We're asked to find the coordinates of point R that would divide OP into two segments such that the ratio of OP to RP is 4:1. What are given? We're given the endpoints of the directed line segment OP, which are O, -5, 2, and P, 7, 6. We are also given that point R lies on line segment OP and divides it into two line segments such that the ratio of OP to RP is 4:1. Okay, so we will start by looking at the ratio that is given and relate it to the given figure. The problem says that the given ratio of 4:1 is OP to RP. Look at the figure, learners. What is OP? You're correct. OP is the whole segment. How about RP? Correct again. RP is just a part of the whole since R is a point on segment OP. What other information can we get from the given ratio? You are correct that segment OP is divided into 4 equal parts and RP is one part of the 4 parts. We now know that the whole OP is divided into 4 parts. Our next job is to locate these 4 parts on line segment OP on the coordinate plane. Let us look at our diagram and find out if we can see these parts. Again, check for that part of this segment crossing an intersection. Let's go. Okay, so we have one here. A second one is here. A third one is here. And another one here. Now, to know if these are indeed the 4 parts, we need to check if their lengths are equal. We will do this by counting the run and rise of each segment. If each part has the same number of rise and run, then they are equal in length, and we can conclude that these are indeed the 4 parts. Let's go. On the first part, the run is 1, 2, 3. The rise is 1. On the second part, the run is 1, 2, 3. The rise is 1. On the third part, the run is 1, 2, 3. And the rise is 1. On the fourth part, the run is 1, 2, 3. And the rise is 1. Okay, so these are therefore the 4 equal parts. With this diagram, we can now locate the partition point R. Again, the ratio of OP to RP, which is 4:1, implies that the total length is 4 parts. More so, it tells us that RP with endpoint at P is one part of the 4 parts. Thus, OR to RP is 3:1, which means that OR is 3 parts of the 4 parts, and RP is 1 part of the 4 parts. Were you able to follow, learners? Look at the diagram, learners. Here are the 3 parts, and here is 1 part. We can now easily position R. Do you agree? Thus, the partition point R is located here with coordinates 4, 5. There you are, learners. We got it. That was easy, right? So, what is our answer? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Now listen, you have seen from the 2 examples that once we get the number of equal parts that the whole segment is divided into, and figured out where these parts are located on the coordinate plane, finding the partition point will be very easy. I will show you other ways of determining these equal parts on the segment so that you will have other options of getting it. We will use sample problem 2 so we can compare our work here with what was done earlier. Remember that our target is to determine other ways by which we can get the number of equal parts and where the endpoints of these equal parts are located on the segment. Take note that if you are not given a diagram with the endpoints of the segments on the coordinate plane, you have to graph them to be able to follow this method. This problem can also be solved without using a graph, but that will be demonstrated on another video. It will require some use of formulas. For now, we will use this method where you will not be required to use any formula. Let us look at the diagram again of sample problem 2. On the diagram, we will draw the run and rise of segment OP. Next, we will make use of the given ratio. The ratio of OP to RP is 4:1. Again, this tells us that the whole segment OP is divided into 4 equal parts. With that, we can count the number of units that the run has. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 units. Remember that the whole OP is divided into 4 equal parts. So we divide 12 by 4. This gives us 3. Now, we count from the initial point O 3 units to the right. Then we will mark where we stop. Okay, we count 1, 2, 3. We continue counting another 3 units to the right. 1, 2, 3. We do it again. 1, 2, 3. And count one more time. 1, 2, 3. Now, from the markings that we placed on the run, we will move up to the segment marking where we stop. Look at the segment, learners. Into how many parts is segment OP divided? You are right, 4 parts. These are the same 4 parts that we got earlier. With this diagram and the partition ratio or part to whole ratio, it is now easy for us to locate the partition point. Do you agree? Now, you might ask if we can determine these 4 parts using the rise. The answer is yes. Here's again the diagram where we draw the run and rise. This time, we will use the rise to determine the 4 equal parts of the segment. We count the number of units along the rise. We have 1, 2, 3, 4. There are 4 units. Remember, the given ratio of OP to RP is 4:1. And this tells us that segment OP is divided into 4 parts. Now, there are 4 units along the rise. So we divide this number 4 by 4 parts. And we get 1. This means that 1 unit on the rise is equivalent to 1 part. We will mark these 4 parts on our diagram. Let's go. Now, we will trace lines from where the markings are on the rise and move towards line segment OP, marking where we stop. Okay, so here are the 4 parts on our segment OP. We can compare these with what we have earlier where we utilized the run, and the one we had with sample problem 2. They're all the same, right? As I said, once you obtain the number of equal parts and their location on the line segment in the coordinate plane, together with the partition or part of whole ratio, finding the partition point will be easy. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a directed line segment is a segment having length and direction. Second, partition ratio is a ratio comparing part of the whole to a part of the whole segment. Third, the sum of the partition ratio gives the total number of parts that the whole segment is divided into. Fourth, the part-to-whole ratio compares a part of the segment to the whole segment. Fifth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you're looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn